Hello everyone. We have started with the curve tracing of polar curves, and in that we have already seen some examples like cardioid and the succeeded problems based on that. And yeah, and the next problem here I'm having is r square is equal to a square into cos 2 theta. Okay, and we are going to trace this curve. This curve is called as Lemniscate of Bernoulli's. Okay, let's start with the first point, and that is symmetry. Okay, to check symmetry, note that what are the key points you are going to note here. Power of r is here even, so when you substitute r as minus r, you are going to get the same equation back, right? And also since cos theta is present, so when you replace theta by minus theta, you are going to get the same equation back, right? So we are going to check each and every point here. Okay, so let's start with the first point. Okay, what was the first point? Replacing theta by minus theta here. When you replace theta by minus theta, and you need to check what happens here, right? So that is r square is equal to a square into cos 2 of minus theta, which is nothing but same, because cos of minus theta is same as cos theta, so this is a square cos 2 theta, correct? So that's why this is symmetrical about initial line, right? So therefore given curve symmetrical about initial line, that is theta is equal to 0 line. Initial line. Okay, the next thing we observed here is power of r is even, right? So we are going to replace r by minus r, right? So therefore what it equation becomes minus r square, which is nothing but r square, and which is a square into cos 2 theta. So equation remains unchanged, so that means given curve is symmetric about pole as well. Curve is symmetric about pole. Right, and the third point is, why I'm considering third point, when I'm replacing theta by minus theta and r by minus r simultaneously in the given equation, that is combining these two conditions together, still I'm going to get the same equation, right? That is, I can write down this as minus r square a square cos of minus theta. So in that case also I'm going to get the same equation, and that is nothing but r square is equal to a square cos 2 theta. So replacing both simultaneously giving me same equation, so it is also symmetric about perpendicular axis, that is y axis. Curve is symmetrical about perpendicular line. So how this curve is going to be symmetrical about initial line? So symmetrical about initial line, that means the curve, the part which is present here, that will also present here also. Symmetrical about pole means the both sided, if this is your initial pole, then both sides to the curve the same thing will lie. And perpendicular axis, so both sides of the curve you need to have same portion of the curve, right? So it is symmetrical about initial line, pole, and the perpendicular line. Three things must satisfy when you are drawing your curve, right? Then the next point is whether pole lies on the curve or not, right? That is the second point is pole, right? So to figure out pole, straight away substitute r is equal to 0. when you put r is equal to 0, what you get? The given equation becomes 0 is equal to a square into cos 2 theta, right? A square goes to 0, so what it remains? Just cos 2 theta equal to 0. So for this is to be equal to 0, this must be equal to 0, that is 2 theta. So I know that cos theta, it becomes 0 in the multiples of pi by 2. So if it is becoming 0 at pi, it will also become 0 at minus pi, and so on. I can consider the multiples also, right? So what is theta? The value of theta is here plus or minus pi by 4, right? So since for plus or minus pi by 4 are going to be 0, so that means the given curve passes through pole. Therefore given curve passes through pole. And one more information I got from this equation is these are nothing but tangent at the pole, right? So therefore what you have, theta is equal to pi by 4, theta equal to minus pi by 4 are tangents at the pole, are tangents at pole. So what you have, tangents at the pole, see this is your theta is equal to pi by 4 line, right? So you can continue like this. This is pi by 4, then in the opposite quadrant this is going to be minus pi by 4. So these are the tangent lines, correct? So let's go to next part. What is the next part? You need to prepare a table using which we are going to actually decide how to draw the curve, right? So let's take some set of values. Since it is symmetrical about initial line, so I'll prefer to consider only up to pi values, right? And I can draw the letter part as it is, correct? So the third criteria is forming a table. I'll write down the equation one more time. R square is equal to a square into cos 2 theta, right? Let's take some set of values, and since it is symmetrical about initial line, it's okay to take only up to pi values, right? This is theta and this is r. Let's take first is let's start with 0, then let's take the next as 30, so pi by 6, then 40, pi by 4 you got as a tangent, so include that. And then the next thing is pi by 3, then pi by 2, then 2 pi by 3, then include 135 as well, pi by 4 ka multiple, that will be great idea. And the last one is pi, right? So let's see. For 0, cos 0 is 1, so r square is equal to a square. Square root of that will be plus or minus a, but I am working in the first quadrant, so I am going to consider this as plus a. Okay, then substitute pi by 6 here. When you substitute pi by 6, cos of 2 into pi by 6 is going to be pi by 3. Again consider the positive root, so this is square root of a by 2. Then the next thing is pi by 4, then square root of a square upon it will be, so this is just a upon root 2. The next thing is pi by 4. When you substitute pi by 4 here, cos of 2 into pi by 4 is pi by 2, cos pi by 2 is 0, so this becomes 0. At pi by 3, so this is cos of 2 into pi by 3, so which is nothing but cos of 2 pi by 3, and which is a negative quantity, so this is negative, so that implies r square is a minus a square quantity, so r becomes imaginary here, right? So in this position this is imaginary, so this angle is not going to be present. There will be no point on the line, right? Then when you substitute pi by 2, it is cos of pi, which is minus 1 again. So this is r square is equal to minus a square, that is square root of minus a square. So again this become imaginary. So that means this on this line also there will be no point, right? Then when you substitute 2 by pi by 3, then again I am going to get the negative quantity. So hence this is imaginary, right? Imaginary. Okay, and you continue like this. Then at 3 pi by 4 multiplied by pi by 4, this become 0. And at pi, this is cos of 2 pi. So here you are reaching again. So cos 2 pi. So square root of a I'm going to consider negative because you are reaching here. Correct? So this is my table in short. Okay. Then next thing is we need to check the asymptote part, right? So since what is asymptote? Asymptote is nothing but tangent at infinity. But so what you need to find out, we need to figure out is to find theta such that r tends to infinity, right? But since cos theta is involved in the given equation, there will be no theta such that r will become infinity, right? So there exists no theta, there does not exist any theta, right? So this implies no asymptote. Correct? And then the next part is we need to check whether there are some tangent at other points, right? So find out tangent at other points. Right? Let's start with this one. So for that, what is the formula? Tan phi, this is equal to r by d theta, and this is same as r into d theta by dr. For now I'll keep r as it is. I'll just figure out what is d theta by dr, right? What I have here, you have the equation r square is a square into cos 2 theta. Differentiate this equation with respect to theta. So what I have, 2r d theta by dr by d theta, this is equal to a square, इसका minus of sin 2 theta and into this 2. So this is minus 2. 2 will get cancelled, right? So what is dr by d theta? Dr by d theta is nothing but minus of a square into sin 2 theta divided by r. Correct? Substitute this value in the equation. So what do we get? Tan phi, and this is equal to r, substituting here, so r will go in numerator, so this become minus r square to a square sin 2 theta. Substituting r square is a square cos 2 theta, and with negative sign divided by sin 2 theta multiplied by a square. This get cancelled. So what remains here? Remaining part is this get cancelled. So what remaining part is minus of cos 2 theta divided by sin 2 theta. Right? Now let's check what we get when I substitute theta is equal to 0 and theta is equal to pi. When theta is equal to 0, tan phi become tan phi, this is equal to theta is equal to 0, so sine becomes 0, so this tends to infinity. So what is the value of phi here? Phi is pi by 2. Correct? When you substitute theta is equal to pi, again sine 2 pi becomes 0, so again this is equal to infinity, so this is again pi by 2. So that means at theta equal to 0 and theta is equal to pi, where the curve touches this theta equal to 0 line, here the tangent will make pi by 2 angle. So tangent will be like this. Similarly for pi as well, right? Now the last part is to decide where the area is present, right? And that is to decide region now. To decide this region, note that cos theta lies between these two values, so as cos 2 theta, correct? So therefore what I have here is when you substitute 1 and the minus 1 part, I'm going to get just for this the part is going to be imaginary, so just don't consider this part, right? Just substitute cos 2 theta is equal to 1, so that means r square is going to be a square. So what is the value of r? R is nothing but square root of a square, which is plus or minus a, right? So that means here my r ka value is lies between minus a and plus a, right? Now let's try to trace the curve. See, as we have discussed earlier, these two are tangent at the pole, and what are they? This is pi by 4 and this is minus pi by 4. This is theta equal to 0, theta equal to pi by 2, theta is equal to pi, correct? And we have find out a table using rule number 3. I'm going to plot the values here, corresponding values for r, right? When theta is equal to 0, I have r is equal to a, so here is a. When theta is equal to pi by 6, somewhere here is pi by 6, so r is root a by root 2, right? A by root 2 will be less than a, so say it is somewhere here, okay? And you need to continue like this, right? Then at pi by 3 and pi by 2, it is becoming imaginary, so that means in between these two tangents there will be area of absence, since here in this portion r is becoming imaginary, right? So the curve will be below this line, here also it will be below this line, right? So and again at 3 pi by 4 it becomes 0, and again somewhere here is the minus a where theta is equal to pi, right? So how that curve is going to be, you need to join this, right? Similarly we need to join this, right? Since it is symmetric about initial line, the part which is above the initial line, the same part will be below. Since it is symmetric about pole and the perpendicular line, the same portion will appear to this side also, right? So it will be like this, right? So this is my tracing of curve. And note that what we have discovered is the tangent at theta is equal to 0 is making pi by 2 angle. So at this point you are having tangent making pi by 2, and also at this point you are going to have a tangent which is making pi by 2 angle with the initial line, right? And this is the curve.